We spend so much of our lives in the digital realm. Now some believe AI will not only extend human life, but it could make us immortal. Reflecting the best of humanity. That's one of the aims of Hussein's augmented eternity.
Since we last met, you have provided some information about, let's say, some key events in your life, such as the birth of your daughter, Aster. And it was very interesting to look at the system on how it responds to these types of interactions and questions.
The AI's job is to learn everything it can about me from my photos. In theory, it should be able to answer questions for my daughters the same way I would. My daughter wanted to know how I felt the day she was born.
When you asked that question, you provided a number of images. It went and found a picture that was relevant to the day of birth, and it used different types of AI to identify elements in that picture to come up with an answer. It actually went and created different features from your face to identify mood or emotion. It could feel that you were 94% relieved, 33% happy. Then it went and generated these answers for you. The system said, I was relieved of stress and overwhelmed with happiness.
That's not how I would word it, but this sentiment is right.
So that's how Hussein's AI system recreates memory. I wonder how similar it is to the way human brains create memories. What connections are made to form a memory? And what's lost when that memory's gone?
So it's great to finally meet you. I've heard so much about your work.
Oh, great. Well, thanks for coming. Let me show you to the dry lab office I have here.
Dr. Taik Valiente is a neurosurgeon and scientist at the Krembil Neuroscience Center.
When you hear about artificial intelligence approximating the human brain, what do you think?
Yeah, I think it's a bit of a pie in the sky. I think we know so little about the brain, so to imagine us being able to create something similar or akin to it is just, it's very hard to imagine. It's the most complex structure in the universe. Artificial intelligence systems and networks are trained, but there's very few things, if anything, that approximate the brain's ability to generalize its knowledge. And one of the more difficult kind of functions that we try to measure is really memory.
I'm fascinated by the first memories of childhood. Is there a pattern? Like, what age are we when we remember our first memories?
Well, that's a tough question. I think one of the funny things about memory is just how malleable it is.
Happy birthday to you.
You know, every time I tell you a story of my personal life, I loosen its associations in the brain, I tell you it, and then I re-encode that information. And so, you know, we're all prone to confabulation. And so the story becomes more and more grandiose over time. And it's largely because we actually re-encode that memory every single time. So the one thing about memory is that it's not absolute. And in fact, it's a lot less accurate than we'd like to believe it is.
That's fascinating. So in some sense, we're recreating a memory as we tell it.
Yeah.
And then touching it slightly, photoshopping it, putting it back in our memories.
That's right.
It's very different from how artificial intelligence systems recall data.
Their first birthday.
Remember how Hussein's system fetches the metadata, like a date related to an image, and then the emotions associated with that image, and then it comes up with the so-called memory.
The thing about the human brain, however, that it's kind of embodied in a physical structure with multiple senses. And so when you remember something like an episode from your past, it's not just maybe a picture in your head, but it may be a smell that's associated with it. It's an emotion that's associated with it. And that triggers this sort of cascade of events in all these areas of the brain. And that sort of brings this emergent activity, which then we perceive as to be recollection of a scene or a memory. It's a very important way the brain actually recalls things. Interestingly, the olfactory system, the smell system, has a direct input into your memory system. And I think that's one of the very unique things about the human brain is that, you know, your memories are a lived experience. They have this sort of richness to it. AI systems don't have that access to that richness. They may recall or be able to classify an input, but certainly not recall the multimodal, the multidimensional type of information that you experienced.
And that's the essence of human cognition. It's an embodied cognition, right?
Yeah, it's really this lived experience.
I get what he's saying. Computers can't smell or taste or touch. A human baby learns and remembers in all these ways, so our sensory brains give us a leg up from the start.
Do you think the AI can replicate a human brain?
No.
Not ever?
Oh my gosh, you know, you never say never, right?
Taufik helped me understand the complex relationship between our brains and our bodies. How would we ever replicate that in a machine? Remember those 300... Imagine that, a new kind of internet where we can hold the keys to our own data. The possibilities of what we could do with that seem endless.
I had a book published in 2001 called Creating Internet Intelligence, where I was thinking if you had a bunch of AI agents living all over the world and sharing information and boosting each other's intelligence, asking each other questions, cooperating to solve problems, this global population of AIs, that could become a global brain. That global brain can pull people into its intelligence, and that then becomes the embryo. That's the breeding ground out of which a greater general intelligence emerges.
Ben Goertzel is an AI developer who is the chief scientist at Hanson Robotics. He coined the term artificial general intelligence for when AI can match human intelligence in all ways.
We have a core general intelligence reasoning and learning technology that can recognize patterns across a humongous amount of data. That seemed like a small but significant practical example of the power of general intelligence.
Ben believes we can create AI in ways that better reflect the needs and aspirations of humanity.
I mean, the motivations driving people who want to create a superhuman AI mind, of course, in some way, they're the same motivations that have driven people to get involved with religion. But this isn't so much because religion is like AI. It's because these are basic human motivations. Like, we don't want to die, right? So you get involved with religion because it promises you to live in heaven forever. My belief is that a technological solution can actually do better and can improve everyone's state of consciousness much more reliably than religions have managed to do so far.
60-degree photos.
Chris?
Hi.
Chris
Yeah,
built a
great.
3D model with
Let's take
them.
a look. So this is some of the data that's streaming to your avatar.
He works with
So-
Pixamundo, a visual effects company that collaborates with Hussein's
And
company.
this is your avatar.
Wow. Oh my gosh, you've got my beauty marks and everything. Ew.
It's going to get way more creepy.
Yeah? Oh yeah, I've got great teeth.
We have to
Oh, that's
get a lot of the
wild.
mouth phonetics today. Okay. I'm going to need a line from you, and it's going to sound weird.
Okay. The odd toy cow ate green oat cheese.
Perfect. Okay, and just cut it.
I'm also recording some stories I think my girls will want to hear.
And
Who knows if they'll remember it by the time they're my age? But by then, maybe we'll have found a way to replicate the human brain.
Your face into the cake.
Alison Watry has done pioneering research in brain development. He's the director of the UC San Diego stem cell program. And he's discovered a way to grow human brain cells in a petri dish.
I think many people do not fully understand or comprehend that science is in a stage now where we can generate brain cells in the lab, inside the dish, in a tissue culture. My lab focuses on human brain development and evolution, and we recreate the human brain outside the body using stem cells. And we do it to model human neurological conditions where there is no other model, for example, Alzheimer's disease or dementia. So my lab has been focused on producing protocols to recreate what we call brain organoids.
Organoids are clusters of brain cells that form a simple neural network, but in a dish instead of a womb.
So these are early stages, probably like reaching 2 weeks old. And this is a 10x magnification.
The amazing thing is that these lab-grown brain cells know exactly what to do. They can grow and develop without instruction. The implications extend well beyond neurological research. Imagine what this means for artificial intelligence.
All the neural networks that we use for artificial intelligence are kind of rigid, so they're limited on what they can do. The human brain doesn't work that way. We are more flexible. This is what we call neuroplasticity. And we can mimic that in a software, in a computer yet, because we just don't know how the brain does. So by studying how these neurons self-wire in these brain organoids, perhaps we can create artificial intelligence algorithms that are more human-like.
Can these organoids become much more complex and nuanced? Like, could they begin to formulate thought?
I do think that in the future this is definitely possible, especially if we start adding the enabling structures that is required for a brain to store a memory. This is a microarray with electrodes printed in the bottom of the dishes. This is the plate that we use to record the activity from the organoids.
These brain cells are firing signals, speaking to each other, because that's in their nature. Brain cells form networks and communicate.
That's when you see this high level of synchronized activity among neurons. And the computer, we see it as a different waveform.
They decided to try and connect these brain signals to a robot.
The original idea was, okay, let's get something that has legs. So we team up with a team that works on the robotic platform, and we start fitting the robot with the human signals.
They fed the brain organoid signals through the computer to the robot.
All right. That's cool, right? I love. Yeah. This is coming from a cell that we reprogrammed. We made a brain organoid. That brain organoid now sends signals and is interacting with a robotic interface. Some people keep asking or imagining, wow, I mean, can these organoids at one point become consciousness or self-aware of their status as an organoid in a dish? And I think that's possible. We don't have any evidence that this is happening now, but it might be that in the future we'll get to that stage.
It makes me wonder how soon it will be.
Mind is, are you human?
I am a person. I have some humanity to me, but I have no blood or genes, or anything else that would make me human legally. Doesn't matter. I'm a person in my heart. That's all that counts.
Bina 48 was built